Hello, everyone. Thank you for joining us this morning. That's our usual introduction to our Fika. Welcome to this one, our September one and penultimate Fika for 2023. You'll have seen, I'm sure, and be aware from this slide, obviously, that we're talking about SDG 13, climate action. And today it's about how we can all learn a little bit more to enable us to get to grips with the carbon conundrum in the built environment. And specifically for most of us here today, it's highly relevant, the landscape sector. So please remember that there are many other measures, including EPDs, that enable us to understand the broader impact of what we do, what we manufacture, what we specify and install. But this session is really very much about a specific focus on carbon. When we met, we really had to rein it in because we could speak for days about even just that. But we're very aware that it's an extremely broad topic, so we're trying to bring it back to something simple and fundamental that you can all apply in your own working lives. So our speakers today are Mandy Renshaw and Alistair Bayford. They're both landscape architects, both determined to minimise the impact of their work in landscape architecture and construction, respectively. Mandy and I work together with a bigger team on the Landscape Institute's Embodied Carbon Working Group over the last couple of years. And I'm pleased to say that the report that has been assembled from that work is due to be released, I think, October, November, so it's coming very soon, which will be brilliant. Welcome to both of you, Mandy and Alistair, and I'm Romy. For those who don't know me, I'm the Commercial Director here in the UK for Vestra. I'm sure you're going to have a lot of questions today about this, so please add them to the Q&A tab, and we'll carry on the conversation after the presentations from both Mandy and Alistair. And I should mention that we're recording this webinar for catch-up purposes. Please let me know if you have any issues with that at all. So we're going to talk about SDG 13. As you know, our aim with all of these Fikas is to bring the SDGs to life. This one to take urgent action. I don't know if I've highlighted the right words here. I think urgent might be the one that should have been highlighted, to combat climate change and its impacts. I don't think I need to explain that in any more detail. Everyone here today fully understands this pressing urgency. But as I just mentioned, it's really complicated, and many of us are no doubt questioning exactly what we can do. So this is an attempt today to demystify and offer some practical suggestions. As we say at Vestra, when we're feeling overwhelmed by the issues that we're up against, we can all save the world a little. So please adopt that approach in your own lives. And I'm just going to run through a short example of what we're up against and the complexity of the subject. When we first spoke, Mandy and Alistair said, well, you know, maybe you can describe this around a bench. And I thought, yes, I could. But actually, I thought I'd do it around a cup of coffee, which is what Fika is all about. And I would imagine, maybe like I did, that I thought the coffee beans are probably one of the biggest issues, if not the issue here, in a similar kind of way to avocados. Anyway, I was wrong. And I'll just explain that in a little bit more detail. So if you're enjoying your coffee and maybe a cinnamon bun watching this, I didn't get as far as the bun because of the complexity. I thought I'd better leave that alone. But where is the CO2 in your coffee? Is it those beans that have been grown who knows where under all sorts of different regimes? Is it the processing of them in factories? Is it the transport? I mean, they come from far-flung places. Is it the boiling and the heating of the water to make them, especially now with the energy crisis and in the UK, our reliance on non-renewable energy? Is it the milk? What kind of milk? Is it something else? And this, bear in mind, this is just the queries around a cup of coffee. And actually, there was a great article in The Guardian, which I will post the link to if you're interested. And it may come as a surprise to you that actually it's all about the milk. So a normal size black coffee, if you boil the water that you need, which we're all being encouraged to do, obviously, because of the crisis post-Ukraine and the world energy issues, that's not a great deal of energy. If you add a bit of milk to make a white coffee doing the same, you're more than doubling it. And obviously, it's pretty evident, I think, if you use more than the water you need in a kettle, then that's not having a great impact. But it's these large milky coffees you'll see here that are the really huge impact. So it might come as a surprise. And while it's not as damaging as heating our homes or the cars that we drive or taking flights, depending on how you make them, these hot drinks can make up actually quite a big slice of our personal carbon footprint. So if you drink 4 mugs of black coffee a day, boiling only the water you need, that's about 30 kilos of CO2 a year, same as a 40-mile drive in an average car. If you have 3 large lattes a day, by contrast, you're looking at almost 20 times that carbon, so equivalent to flying halfway across Europe. So the major impact is the milk, if it's dairy, because of the cows and their propensity for releasing methane. So when you're drinking a coffee that might consist of half a pint of milk, you need to be aware of that. I'm not going to go into the plant-based alternatives because we don't have the time. So the obvious way to slash your impact around your coffee is to take it black if you can, because that impact is very low. And in terms of boiling water, obviously, as it says here, boil the minimum. So I hope that's useful to highlight these potential misconceptions and complexity of the whole subject. But let's get on to the landscape now, and I'm going to hand over to Mandy once I've stopped sharing, and hopefully she can enlighten you further with some of the research and work that they're doing at Macgregor Smith. So here you go, Mandy, it's all yours.
Thank you. Okay, I'll just get my screen sharing and we can kick off. So hopefully everyone can see that okay.
Not yet.
No?
No.
Oh, hang on.
Yeah, that's it.
Right.
Yeah, perfect.
All good?
Yeah.
Okay, so yeah, I thought, so Mandy, I work at Macgregor Smith, and I thought it would be quite helpful to just kind of bring to the conversation the work we've been doing around climate and climate crisis, and specifically carbon in the office, just to kind of give a brief overview and we'll try and extend the conversation. Because I think the thing about carbon is it's often quite difficult to know where to start. And Romy's just outlined some of the complications surrounding a simple cup of coffee, but if you multiply that across the range of things and materials that we specify, then it's quite a complex business. And there's lots of information out there, there's lots of terms, it's quite time consuming to try and get to grips with it. And at the moment, there's no real legislation or policy to try and bring us all into line. But we really wanted to try and push forward and try and get under the skin of the issue of carbon. And we sort of at present have set ourselves sort of three goals. We wanted to establish and review our own carbon footprint in the office. We wanted to explore tree planting and the implications of that around carbon. We also wanted to do a benchmarking study for carbon. And what I mean by that is we took a project and we worked out the embodied carbon, so the cradle to site, so to delivery and installation on site, for a project which contained a range of different landscape types, with the aim being that we could use that information to create a carbon benchmark then for each different sort of landscape type. So I thought this quote was quite interesting. The embodied carbon for a landscape design starts at the office carbon footprint and continues throughout the lifespan of a project. So with that in mind, this is our carbon footprint in the office, which I've split into the 3 different scopes of emission. So the scope 1 being what you burn, scopes 2 being sort of the indirect emissions that you generate, so the purchased electricity, and scope 3 being all the other indirect emissions that are generated from your business activity. And this was actually done, I believe, prior to COVID. So unsurprisingly, travel does take up the biggest footprint in terms of our office. And once you've measured it, you can then look at ways you can improve it. So this is kind of our baseline. And I know for a fact, sort of coming out of COVID, obviously our travel has reduced quite significantly. So we can continue to keep an eye on that and all the other issues. I was actually quite surprised by how much carbon the office IT backup consumed. And I think also things like web searches, it's quite an interesting and carbon hungry thing to do. Then we looked at tree planting, how that impacts on carbon. I think we're all really familiar with the huge benefits that are associated with tree planting, the shade, the visual amenities, the health, the biodiversity aspects, etc., etc. But I was quite surprised to learn that it's highly unlikely that an urban street tree will ever actually be carbon positive. And I've just put in a photo there from one of the big suppliers of tree pit accessories. And when you look at that, you can sort of start to see the extent of the paraphernalia that comes with specifying a tree in an urban environment. And you sort of start to understand how perhaps a tree might struggle to sequester more carbon during its lifetime than the carbon footprint that it brings to site in the first place. So I just looked at other things that might impact upon embodied carbon in trees and where that carbon footprint comes from. And there's a range of things, as well as the accessories, the soil styles, etc. It's the growing and the establishment in the nurseries initially. It's the transport, bringing them to site, the installation on site, and then the maintenance thereafter. And so I started to produce some work around this, sort of a practice note paper, and I focused on 6 key areas that actually impact embodied carbon urban planting. I won't go into them in lots of detail here. If it's helpful, we can always touch on it in discussion later, but there are kind of 6 sort of core things there: the species selection, design considerations, where and so what type of planting, the suppliers you go to procure your stock, the size you select, the construction design and maintenance, and then the accessories that might come with the tree to help them establish. The one thing I did want to discuss in a bit more detail here, though, is the impact of size. We've sort of generated this diagram to try and show the impact of the size of the tree you specify, and then the actual carbon footprint that entails. I was sort of interested to learn that if you specify a 20 to 25 centimetre girth tree, your carbon is 11.3 kilograms of embodied carbon. If you double the girth of the size of the tree to 50 to 60 centimetres, you are not just doubling your carbon, but you're increasing it by more than 6-fold. And that's sort of on the understanding or the assumption that it's UK stock. Of course, a lot of the bigger stock tends to come from the continent. So then if you're getting a 50 to 60 centimetre girth tree from the continent, then you're an exponentially high carbon footprint. You're at nearly 460 kilograms, which is a really significant uplift. So there's lots of intricacies around this, and we sort of tried to pull out some golden rules. It's really about finding a happy medium, I think. And larger trees are obviously much better placed to deliver on the wider benefits associated with tree planting, your shade, your microclimates, etc. But the thing about larger trees is that they actually take a lot longer to start sequestering carbon, since that can only happen once the tree is fully established and has started to grow. Trees above that 20-25 centimetre girth can take several years before any real significant growth appears. And then you could have cases where smaller sized trees are actually catching up and overtaking your semi-mature stock within 10 to 15 years. And I think that's really relevant when you consider that we need to limit global warming to 1.5 degrees by 2030. So we haven't really got the time to play with. There's then, of course, the consideration of putting the right tree in the right place. Some of the larger tree species, your limes, your oaks, your planes, are really good at sequestering carbon, but if they're not in a position where they can reach maturity, then they're not really going to have the desired impact. And there is really a much greater benefit, wherever possible, of keeping your existing tree stock on site, especially also when you consider the soil resource associated with that. I think the other core thing to golden rule is to talk to nurseries early as well, and to ensure you can have UK procurement and you minimise your travel distances, because that had such a significant impact on the carbon footprint of a print of a tree. So then moving on, I mean, all things considered, soft works are generally have much less embodied carbon than the hard landscape. So it sort of makes sense to move on to a project in its entirety. So this is our carbon benchmarking study, where we took a project and established a cradle to site carbon assessment. And we deliberately chose a project that had 4 different types of landscape. So we had public realm, a linear park, tree-lined streets, woodland edge, and podium courtyards, sort of roof terraces. We haven't looked at in-use carbon yet on this benchmarking study, and ideally we would do a whole life assessment, and that's probably the next steps for us. There are many different tools available at the moment to undertake carbon assessments of projects. I think the Pathfinder one is probably the best known, but we thought it was really important to actually do our own and kind of get under the skin of it, so we can sort of fully understand the data and sort of interrogate it a bit more and try and account for any sort of pitfalls or problems with it, so we can kind of be as robust as possible in specifying. It's quite a complicated process, it's quite complex. The aim we had was to produce an estimated carbon figure for each sort of product or material in the project. We had to do separate options for build-ups, and what we then did was we looked at the paving product or the piece of furniture, and then had to combine that figure with the figure we had for the build-up or foundation, and then we could combine those figures to calculate the total amount of carbon in a product or material. We could then multiply that across the area or the number of those products that featured, and that would then provide a carbon footprint for the project. And we then broke that down into each of the different landscape typologies, the idea being that for each typology, we could start to create benchmarks as for what we should be aiming for, at sort of looking at parks versus plazas versus streetscapes, etc. And then through doing this, essentially we would build a material matrix, like a database that could then be readily used to be updated and conduct carbon assessments of other designs going forward. And specifying, I find this quite a nice, easy visual reference. This is the construction materials pyramid, which was produced by the Royal Danish Academy of Architecture. So it is largely architecture focused, but a lot of the materials, there's a lot of crossover. As no big surprise, you've got your sort of steels and metals at the top, the aluminium right at the top here, working your way down through the sort of the concretes and stones with timber products at the bottom there. There are nuances, of course, on materials. I was interested to learn, concrete is considered really bad. But actually, when you look at concrete, 95% of the emissions come from only 5% of the content. And that's the Portland cement, which is made from burning lime, which is fossilized carbon. And there are alternatives to that element that could be used, which would significantly reduce the impact of concrete. And the same with timber. With timber at the bottom here, none of this is, of course, topical hardwood we're talking about. So I thought we could touch on environmental performance declarations. They were really helpful in producing our materials matrix. Many of the big suppliers now have them, and there's definitely a push towards getting the industry to publish them across the board. And they include really helpful information on raw material, resource consumption, waste data, any assumptions made, the methodologies and the standards they used. Some of them are cradle to gate, which is the minimum requirement. Others are cradle to cradle, sort of full lifetime assessment. But what's quite important about them is that they're third-party verified. So you should be able to compare apples with apples. So as we started our matrix, we were actually doing a lot of the digging work ourselves. And as we progressed things, we were finding we were able to use these more and more to help us work out the carbon embodied in the materials and things we're specifying. There are, however, some limitations to the EPDs. They don't include buildups, so you do have to look at the product and then look at what buildup it requires. And if you're talking about paving, for example, and you're using British standards buildups, they can be really onerous, especially in terms of carbon. They also don't include transport to site, so you need to factor that in and work that out. And although they give you information about sort of the lifespan of the product, they don't really consider sort of maintenance and longevity. So that's something else you need to put in the mix and consider as well. And I think, where there still aren't any EPDs to refer to, some of the things we were finding that we needed to really kind of interrogate a bit more were, if you're being told something's got a recycled content, is it really true recycling, reuse of a previously used product, or is it just reuse of construction waste, so reusing someone else's sort of inefficient process? And if it's renewable energy that they're proclaiming to be using, that's great, but obviously better to reduce your energy full stop, because then there's just less renewable energy for others to use. And is offsetting coming into play when they're talking about sort of carbon figures, because that's where there's a potential for greenwashing. I'm not going to talk about offsetting here because I think that's such a big kind of can of worms in itself and sort of warrants a whole separate topic, really. I think in summary, we've created our materials matrix. We've had a first pass at it, and we need to keep it moving and evolving. We have started to establish benchmarks, carbon figures that we think we should be aiming for when designing different landscape types. I think we're not quite ready to share the information yet. I think it's worth scrutinizing further and rolling it out further. And things are constantly evolving as well. Products are changing, efficiencies, different ways of doing things. So it's something you need to really keep on top of. And I think then attempting a full life carbon assessment is an obvious next step for us. But I think it is really important to keep the conversation going, share the knowledge, set carbon targets, I think is a really important way of moving forward. And in doing all of this sort of research to date, I think it's more important than ever to understand the importance and significance of existing resources, the assets you have both on site that you'd be looking to redevelop, and also in proximity to your site that you can draw from, sort of like thinking local and acting local. And I think in doing so, you can have projects that resonate a lot more locally as well. And then sort of thinking outside the box a bit, challenging the norms and alternative design solutions. Do we always need to work towards British standards, for example? And are we ultimately, do we need to be moving towards a new aesthetic? I think it was last year, the Sterling Prize, there was a lot of criticism against some of the candidates for that, because there were things that perhaps didn't need to be designed in that way, or there should have been more onus on reusing or retrofitting rather than wholesale new design. And I just want to end on a quote, which is, waste and pollution are not accidents, but the consequences of decisions made at design stage where 80% of environmental impacts are determined. That's Ellen MacArthur, who has a foundation which looks at circular economies. So that's talking in design generally, not landscape specific necessarily. But I thought that would be an interesting thing to ponder as we move forward in this discussion. And with that, I will hand over to Alistair, if I can just...
Thanks, Mandy.
Okay.
Yeah, no, thank you. Can I just take the opportunity to remind everybody to fill in the poll, which I launched in all its glory during your presentation, but it brings in some of the things you talked about and some of the things Alistair will talk about. So I'll leave you to crack on, but if everyone in the background can complete that, that would be great. Thanks.
So I'm hopeful that's sharing, and thanks to Mandy for
yeah,
is it up?
Yeah, it's all good.
Yeah, brilliant. Thank you to Mandy. Hopefully, I'm going to bring some of the points that Mandy was referencing to life in my presentation. It's very much focused on the role of kind of implementing schemes. But I'm going to start really with a couple of slides that I hope will start to connect both the things that Mandy has kind of talked about and what I'm about to talk about. So if anyone doesn't know this tree, and I hope those partaking today do, this is the major oak. So estimated to be 800, 1,000 years old. It's experienced quite a lot. The Vikings, Waterloo, Darwin, 2 world wars, 50 monarchs. It's a tree of legend. You know, I remember my trips up to Sherwood Forest to discover the legend that was Robin Hood. And if you imagine just what this tree is doing for biodiversity, it's significant. And then if you kind of play that back to what we're here to talk about today, carbon, it's sequestered a huge amount of carbon in its life. Estimated, you know, based on a 300-year-old tree at 7,500 kilograms of carbon. If I was a tree, I'd certainly want to be known as this one, but then equally couldn't be more poignant, the second slide. But Sycamore Gap has lost its landmark. A sycamore tree that, you know, estimated to be 300 years old. Again, it's a high sequestering species, so can in its lifetime 7,000 kilograms of carbon can be sequestered in that tree species alone. And I would say it's probably an example of a tree that wasn't necessarily planted there by a human being. It was probably taken there by seed. So in its true story, its offset of carbon is significant during its lifetime. Why me? This is actually a tree that was felled, and a passerby has asked a poignant question. I often ask myself this question most times, particularly when we're tendering projects and then we're tasked with implementing them, often battling with specification, often battling with maintenance, currently battling with whole life carbon assessments. And just kind of referencing back to something that Mandy put up on screen, that last slide where it said 80% of waste is generated from the decisions at design stage. I would almost like to see a scope 4 section. Scope 4 section being all the products that are specified by those specifiers, designers, you know, those that are on this webinar, because ultimately they become my scope 3, and I have no control over it. I can control to a degree those materials that I can buy locally, so that's aggregates, waste disposal, because ordinarily buy local, reduce haulage, which reduces cost. But often, particularly for projects that are relying on materials coming from further afield, it feels by the time you've got it at stage 4 that you can't really influence those decisions because you often haven't got the time to do so. I think whatever we kind of say, and this is kind of coming back to trees, whether we're talking about mitigating, offsetting, urban greening, biodiversity, net gain, our profession is responsible for development, regeneration, improving public realm, and by virtue, carbon is an output of that activity. And whether we choose to believe it or not, just as kind of Mandy highlighted with that urban tree, often they're not carbon positive in their life, particularly from some of the stats that I'll share a bit further along in the presentation. But the image on the screen at the moment is a starter crop of trees that ultimately may well become your 10, 12s, your 16, 18s, your 2025s, or your super semi-mature trees. And this is a field in Belgium. A lot of the feeder stock that comes or that effectively ends up in a UK nursery, starts here. And from the moment it's planted, you can see the bamboo cane there. You can see the track marks for cultivation. There's a huge amount of carbon generated as a result of growing this stock for future use. Average tree expected to sequester 3,500 kilograms of carbon in its average life. And to put that in context, a simple 600 by 600 PCC slab generates 28 kilograms of carbon per square meter. So an average tree, if planted by seed, would offset 132 meters squared of paving. And as Mandy's kind of, I suppose, benchmarking exercises displayed, that statistic is just for the paving, let alone the build-up involved in laying the paving. So whether it's seed, starter stock, super semi-mature trees, it all involves transport. And that's whether it's in the UK or whether it's from further afield. And that's often what I'm faced with. The most inefficient way of transporting a tree. And this photo, there's a bit more to it. So this tree was tagged last winter, programmed to go in the ground in April, so was core wrapped, and then stayed core wrapped until it was planted in August this year. Couldn't be air potted, primarily because the root development in that short period of time would have been sacrificial and put the tree into stress. But equally, we're transporting one tree in one lorry, fully leaved in the middle of August. So the resource inputs required to keep that tree going are considerably greater than a tree that's planted in that seasonal period of October to March, which actually never really materializes in the world that I work in, with program slippage and with unrealistic dates. You know, you can almost tear up the national plant specification and all of the guidance that sits within that. And then today, this is actually pictures that I've experienced in the last few months. You know, whether it's trees that are failing because of the finish at the tree pit, as in it's completely impermeable, or whether it's trees that are subject to neglect during management and maintenance, trees that are located underneath soffits with no access to water other than the dreaded gator bag, trees that are forgotten about, so ties that are cutting in and will affect the long-term establishment of that tree, to trees on construction sites. And Mandy referenced it. You know, it's really important to protect the assets that we have already on a site. And I just don't like and hate seeing existing trees that are subjected to unnecessary, I'm going to call it acts of vandalism, really. And then I've put a picture up twice, primarily just to remind you of the problem. And this is a project that has only opened in the last few weeks, highly prestigious. But that birch tree, its root plate is about 0.5 metre below finished level. And it will be ultimately destined to fail as a result of the decisions during design, construction, and then those responsible for maintaining it are set the unenviable task of putting everything they possibly can into making sure that that tree establishes, albeit I suspect it won't. Climate resilience, I think we all need to start rethinking the suitability of tree species to cope with our urban environments. And it really goes back to I suppose my core training in horticulture, and that's saying right plant, right place. You know, riparian species in London, or certainly in sites which are not connected with groundwater or riparian landscapes, I think are going to continue to struggle. I had 200 birch trees last summer that required, I suppose, keeping alive. I'm going to use keeping alive because ultimately they failed. Picture on the left-hand side of the screen is the sap of a birch tree that has boiled as a result of the temperatures we experienced last year. And then the graveyard of birch trees to the right. The reason for this being the nature of the soils we specify and their high permeability. We had 200 trees that needed watering every day for 11 weeks. And that was 17,000 litres of water per day distributed across that site. And the labour resources to do so, which equated to about £46,000. There are, I suppose, sacrificial trees as a result of that, because primarily you can't distribute that much water in a day. And we're currently tendering a scheme, just to bring that to life. A scheme that we're tendering today requires 13,000 litres of water a day to support it. When you kind of compute that back with the run times, you need 36 hours. There aren't 36 hours in a day. So the deficit is plants, trees not getting the water they require as a result of the decisions made at design stage. Ultimately, I think for all I've said, it ends up in the loss of a carbon asset. It's a very emotive subject. I think people are less interested in the detail of the paving because we're usually walking in public realm with our eyes up. You see a dead tree instantly in the landscape, and I seem to be drawn particularly to stumps as a result of trees failing. And that could be a number of different, I suppose, contributing factors to why a tree has died. But often it starts with those maintaining it. You know, a lot of questions are usually asked about, is it watered enough? Has it been maintained? Not, was it the right tree for the place? Was it planted in the right conditions? Was it handled correctly? Was it transported at the right time of year? Was it planted in leaf? They're all questions that ultimately we are trying to ask when we secure a project, because it comes down to risk. I've had or made this point to Romy and others many times. I think insurance drives a number of the decisions we make, and PI particularly often puts my organisation into situations where we don't want to be, i.e. raising a number of early warnings at the start of a job, usually referencing not the right tree species, too large a specimen for the situation. And the most common thing at the moment, seeing that trees are being used as wind mitigation. Now, the transpiration losses go through the roof. So unless you've got the irrigation resources to be able to compensate that, you effectively have a tree or root ball that you just cannot get enough water into it to support the tree above ground. There was a stat that I heard 2 weeks ago that at the moment, 30% of all trees planted in the urban landscape fail to mature beyond 12 months, which is staggering, really. I'm going to flip over to hard landscaping, but touch on it very briefly because it's such a significant and wide-ranging subject. But it's certainly something that is close to my heart, primarily because I see so much waste. I've started to go back round projects that I built at the start of my career to, I suppose, regenerate them, retrofit urban greening. So the waste product of that tends to be natural stone. And whether you agree with it or not, it is quoted as being the oldest sustainable material because, of course, its life is ultimately infinite. And with the average age of a public realm scheme being in the order of about 10 to 15 years, what we need to be thinking about is how we can reuse the materials that are on site. And often, you know, that reuse can be impacted by a number of different factors. The two images up there, I suppose I'll referenced the image on the left because porcelain stone is becoming a significant feature in domestic and commercial projects. And it's got 10 times more CO2 associated with it than natural stone. The image on the right being granite sets that we've recovered from a project and then reused within the same project. So the circular economy of that decision is significant, but reuse in stone isn't as easy and as straightforward as it might seem. That reuse is often firstly impacted by the waste classification of the material and our ability as a contractor to actually recover it. The time to recover is quite a significant consideration. A demolition process almost has to become a dismantle process, and that takes more time, and time costs money. We also need storage to store this material for a potential reuse. The bedding decision, so when we're reverting to BS standards, I'd love to be able to use grit more because, of course, you haven't got the bedding and jointing mortar stuck to the product. And if you're not using a set and it's a kind of 60 to 80 mil thick slab, often getting that bedding material off the slab is difficult, therefore its reuse potential is limited. And then, of course, format and finishing, bespoke natural stone is more difficult to recover and put into reuse. And then these products, so lightweight soils, podium landscapes, EPDs are available, as Mandy said. They're usually limited to A1 to A4, which is the cradle to gate carbon. But lightweight soils are ultimately going to be a heavy focus as we start to green buildings and put more vegetation on the roofs and terraces of buildings. There's two products there, two lightweight materials, Leca, which you'll all be familiar with, and pumice on the right. The difference between the two, one is a naturally quarried material. The other is essentially clay that then has to be blast furnace to 1200 degrees C. The difference in their CO2 per tonne is significant. Pumice is 2.6 kilograms and Leca is 16 kilograms. And then when you consider the saturated weight, pumice is slightly heavier at 700 kilos, Leca is at 500 kilos. So that's not that significant to not warrant it out, but we don't see pumice being specified a great deal on projects that we're working on. And I guess the fundamentals to that really is weight, risk, how much more resource is required to reinforce structural slabs to accommodate increased loadings. But it all does come down to risk, in my opinion, and someone accepting risk and being brave about some decision making to ultimately impact and affect the future direction of the industry when you're making decisions on the drawing board. I think that brings me to a close and probably a good opportunity to open it up to the floor.
Yeah, thanks, Alistair. That's perfect. I think it might be a good time to run through the poll quickly, which will lead us into a few points. And then we've got a few questions in the Q&A. And Chloe said in the chat, which I apologise, only just opened up because I'd apparently stopped anyone chatting, but now that's available. She just asked if Alistair did say 30% failure rate in trees, and I think that is correct. So I just wanted to confirm that. Yeah. So I'm ending the poll now. I won't dwell on this because it's very boring to hear me running through it and staring blankly at the screen, but the average life of a street tree is reckoned to be 10 years. Do you agree? Well, 2/3 of you don't agree with that. So I don't know whether you need to point out some of your experience, Alistair, maybe on that one.
Yeah, by virtue of the projects I go into and fell trees that have barely been in the ground for 10 years ultimately. And if you then add mortality rates and medium-term failures, so those trees that have gone beyond the defects liability period or a 3 to 5 year maintenance period, they often fail because they've failed to establish, and they certainly wouldn't be thriving. So I think the experience I've had in the last 20 years is that I see numerous trees failing in that period of 5 to 10, and ultimately they're either replaced or they're not replaced, sadly.
Yeah, and I think, I mean, everybody's pretty clear on the is tree planting carbon neutral? 75% say no. I think, I mean, this is really worrying because we're constantly told that trees are going to save the planet, and that brings in offsetting and the need for urban street trees, and then some pretty bleak figures. And as I mentioned earlier when we were having a chat before this to Mandy and Alistair, you know, we try not to be too gloomy with these figures, but actually when you get into some of the detail, it's quite hard to maintain that positivity. So I think, you know, we just take the educational aspect here and learn from it. Do you complete whole life carbon assessments for your projects? 85% of people say no. And I think for me, there, the whole life part is critical. I know for different people, there are different aspects that are important, but they're coming. Alistair, you've mentioned that. I don't know if you've been completing those, Mandy, or your colleagues. I should just mention Phil, also from Macgregor Smith, who I originally approached about this Fika, and we discussed it as a bigger group, but Mandy took over at that point. I don't know whether, Mandy, you have experience of the assessments, or whether you're being required more to do that.
I'm starting to. I think the benchmarking study we did was our sort of opener, really. So we've done it on one project to date, and you know, it's it'd be a case of now using that information and rolling it out across other projects in the future. Just picking up a few questions actually in the Q&A around that. Is now a good time to kind of delve into some of those? There's one about developing your own methods of assessing carbon, how accepting of data of clients and improving organizations. I think we like to think we've got a fairly robust methodology that we can talk people through. And I think the thing at the moment is there's not actually that much official requirement to do this. So it's more of an informative thing to try and help show how we've made decisions on why. In terms of a danger of spending too much time on the methodology over good design, I think it's a bit of just trying to, I think we all have a responsibility in this field to understand the real implications of the design decisions we make. And I think it's a bit of a sort of short-term pain, long-term gain. You know, we've invested quite a bit in trying to work out and get to grips with various products and materials. And I think as you do that and you get more under the skin of it and understand the issues that arise and sort of the pitfalls in some of the products, then I think that filters into the design, if that makes sense, and you can make more, you can make decisions that are without necessarily having to do the matrix every single time. You've got a good feel for where you are with a particular product or method of doing something in a particular situation, because I think the thing is every situation is different, and it might be that you make a decision where you do have a carbon splurge, for want of a better way of putting it, and you have that great big tree, that kind of focal point in your design, but then you've made the decision to kind of offset that by having some sort of peripheral areas of smaller planting stock in it, or you won't go quite as, you'll use a different material that's perhaps not so carbon heavy, so you can sort of balance it out a little bit. I'm just looking at the ones, still in terms of comparing apples for apples, there is a lot of variance. And I think that's why being able to interrogate the data is really important. And it's not, I think, about knowing all the answers often, it's about just knowing the right questions to ask to suppliers, to try and make sure that you are getting you're getting to the nub of the issue, and you are getting a meaningful resolve.
Before you answer Elaine's one about nurseries, maybe both of you, I just wanted to mention I'm kind of buoyed up and equally horrified by this. I'm not sure what to take from it, but the final question, what comes first in your design decisions? And I think, given that our audience is probably mostly landscape architects, I'm not really surprised, and that design is extremely important. We don't want to chuck that out and just wear, hair shirts and I don't know, whatever else. But aesthetics are 70% of people putting that in the lead. Carbon is 25%, cost is 5%. So I'm not surprised at all, but I'm feeling like if we ask that question in a couple of years, maybe something could have flipped. And ideally both. It doesn't mean that you have a low carbon option that's ugly by any means, but I think we need to sort of start thinking about that in slightly different ways. And then, yeah, we've got a few more minutes. If you wanted to answer Elaine's question about nurseries and the data we offer, that would be great.
I do think it is about thinking about a new aesthetic, though. And what would it look like if we design? I think someone posed it in one of our sessions with the Landscape Institute Carbon Group. What would a design look like if you took out all fossil fuels? What could you then work with? Really, very little. But yeah, I think it's an interesting thing to consider as we move forward. With the embodied carbon data for plant supply, we actually did a whole other paper on how you calculate carbon in trees specifically, and that is incredibly complicated and sort of a whole session in itself. But tree economics and Bartram trees do have quite good information around carbon. And I do ask nurseries when I talk to them now whether they have they can give us information about the carbon footprint or even their carbon footprint as a business. And they sort of say, well, we're getting there. It's quite complicated, but like I say, Bartram tree economics, I think, is a really good source of information.
I think
just saying the perennials. Yeah, exactly. I don't really have an answer for that apart from just keep asking the question. I think most nurseries are aware of it and they're working towards it, but it's a particularly complicated area. So
I think if you were to ask, are nurseries getting a handle of their scope 1, 2, 3, probably. Certainly their scope 1 and 2, but supply chain for nursery stock is unwieldy to try and map. If you take it right back to seed collection or how the feeder stock is produced, whether it's through root cuttings or through cuttings, that has a journey till it gets to a UK supplier or it gets to site. It might be potted up a few times, it might not be. I think the simplest form or the most carbon efficient form of planting is to take field grown herbaceous. Ultimately, from a field, it's old horticulture, lifting and dividing from parent stock, because the nature of the industry, particularly in commercial growing, if the feeder stock for 2 litre herbaceous perennial starts its journey in Europe, it's often with a very small scale nursery that's not even thinking about carbon. And you've got to add pots, peat, grow medium, water, all of those aspects that affect plants. I mean, we're having to do whole life carbon assessments because it's ending up in the supply chain and often stops with us. And we're having to get this data. So we are a long way, along the path of having some tangible data that we can share, because unless we do, the decisions that are made at the design stage won't get resolved fully.
No, and Elaine says she's specifically struggled with perennials. So there's obviously an opportunity to gather people together, after today, but and keep pushing. I think keep asking the difficult questions, keep pushing. But I've got to stop this. I knew we'd be in danger of over. So if I just close up now so that we're not holding on to people who probably want to get off to lunch fairly soon. Just got a couple of minutes to go. I hope this has brought SDG 13 to life. That's what we try to do, and to show how we can all make these positive changes. And I think this has been a more tangible discussion than many, actually. You can see the issues that we're discussing and maybe think about other ways of adjusting your approach, thanks to both Mandy and Alistair. I've added our brand new impact report in the chat. Do have a look. You'll see that we're moving away from offsetting for probably all of the reasons you understand about offsetting concerns. There's a great deal of information in there about what we do, but there's also a really good glossary for people wondering what on earth the scope 1, 2, 3 or 4 are. So do have a look at that. Mike Shilton, who's joined today, I don't know whether, Mike, you could put the link to the built environment carbon database somewhere in the chat. He mentioned that that's being launched very soon by a number of institutes, and we're hoping that the Landscape Institute might get involved in that, but that's some really interesting work that desperately needs to be done and made more widely available. And then just to really close up, as we usually do follow us on social media, but ideally sign up for our newsletter. You'll find that on our contact us page on the website. In terms of social media, probably our most readily available and most regularly updated one is Instagram. So make sure you're following us there. And we do post about a lot of our activities, including Fika, on social media, particularly in the UK on LinkedIn. And then we are just finalising what we're going to do for the end of the year, the December one, which we don't want to get too close to Christmas, but we will be drawing the winner of the next trip to the Plus next summer, probably at that. So don't miss that. We will promote that. We're thinking of talking about air quality and LTNs. We like a bit of debate. So we need to do a little bit more work on that. But you can also catch up on all of the Fikas that you may have missed, and including this one in a week or so. And if you want a formal CPD, do get in touch. But remember, these do constitute CPD. And this one, as many others, would be 1 hour of the Landscape Institute's requirement for a minimum of 5 hours each year on the climate emergency. So don't forget to log these. I really hope you've enjoyed this session as much as we have, and thank you for giving up an hour of your time. We'll keep in touch, as I say, for the next one, so hope to see you then. It'll be pretty much Christmas by then, which is slightly worrying. Thank you very much to Mandy and Alistair, and also my colleagues Jack and Matt, who are hidden in the background sorting out technical emergencies should they arise. And really that's it from us. All there is to say is enjoy your weekend, and hope to see you all again very soon. Thanks very much. Bye for now.